July 19th. Alright, let's do this. Congratulations, 200 days badge 2025. Alright, I got 200 days. How do I get a badge? Do I get a badge? Maybe I do, maybe I don't. Alright, I'm going to delete duplicate folders. Due to a bug, there are many duplicate folders in a file system. You're given a 2D array paths, where path I is an array representing an absolute path to the ith folder. For example, 1, 2, 3 represents to this. Okay. Two folders, not necessarily on the same level. Two folders, not necessarily on the same level, are identical if they chain the same non-empty set of identical subfolders and underlying subfolder structure. The folders do not need to be at the root level to be identical. If two or more folders are identical, then mark the folders as well as their subfolders. I don't understand this sentence at all. Two folders, not necessarily on the same level, are identical if they contain the same non-empty set of identical subfolders and underlying subfolder structure. The folders do not need to be at the root level to be identical. If two or more folders are identical, then mark the folders as well as their subfolders. I think this is setting up the rule of how to determine if two folders are identical, which is if they, okay, my understanding is if you consider the root folder and then it's like two subtrees. Two subtrees. Like if they are the same, then they become identical. Actually, I don't know. For example, folders, these two, A, B, in the file system below are identical. They, as well as the subfolder, should all be marked. Identical. Hold on. If they're identical, if they contain the same non-empty set of identical subfolders and underlying subfolder structure, the folders do not need to be at. Oh, the folder do not need to be at the root level to be identical. Okay. If two or more folders are identical, two or more folders are identical, then mark the folders as well as their subfolders. Mark the folders as well as subfolders. Okay, let's keep going through the example. If the file structure also includes the path BW, when the folders A and B would not be identical, know that AX and BX will still be considered identical even with the added folder. I still don't understand how to determine if two folders are identical. Do I have to have all of them to be the same for a subfolder structure? I think so. I think what it says is even if the top level you can have a different subfolder, but if you have some subfolders that are identical, those count, which makes sense, right? Which makes sense. Once all the identical folders and their subfolders have been marked, the file system will delete all of them. The file system only runs the delete once, so any folders that become identical after, okay, return the 2D array answer containing the path of the remaining folders after deleting all the marked folders. The path may be returned in any order. Okay, let's see. So in this structure, right? Basically, huh? What? Wait, what? I have ACD, AB, CDDA. Wait, hold on, let me do it again. So I have A, C, D, A, B, C, no. Each one is a folder. Wait, hold on. What each one is? So you have three. Then you have put everything together. That means you have. Okay, hold on. I think I understood it wrong. So when you say A, that's just by a folder by itself. So basically, we have A, we have a C, we have a D, and we have AB. We have CB, and we have DA. That's not right, because each one is its own, so they don't really form this. So basically, we just have A, C, D, AB, CB, and DA, right? The absolute path to A, absolute path to C, absolute path to D. Two folders are identical. So we sort it first. Okay. So you have these folders first, and then you try to get their subfolders. Two folders are identical if they contain the same. So basically, you mark this because these two are identical. So I mark this, I mark this. So I return this and this. Okay, I still don't understand very well. Let's try this one, try the second one. So if I sort it A, C, I have W, right? So I have A, C, W. Then I have A to B, C to B, A, B, X, A, B, X, Y, W, and W, Y. So if we find identical, I was gonna say with Y and Y, so only these two are identical, so they got deleted. So we should return A, C, A, B, and C, B. have I don't know, what if you have A, B, C, D? No. Simple. A, B, A, B. What is this going to be? Just test it out. Oh! You cannot have duplicate paths. No two paths lead to the same folder. For any folder not at the root level, its parent folder will also be in the input. Okay. So this situation is not possible. So it's a wee bit simpler. So yeah, we sorted because. So would it be possible, like, without do this? No, because for any folder not at the root level, for example this, the parent will always be there. So yeah, so we can sort it. Then we have the one level, right? We have the one level, and because none of them are, they're all distinct, right? They're all distinct. So for each, we go to the next level. So yeah, it's like a try, right? But what you want to know is finding out all the things that you need to mark with deletion, right? You need to mark with deletion, and when you delete, it's starting from the kind of the root, not the root, but the current root towards the end. So the job now is let me think about it. So can I say I cannot do AB without A, right? So if I want to do ABXY, they say for any folder not to its parent, so for ABXY, I must have ABX, I must have AB, I must have A. So if I sort everybody, right? I sort everybody first by, how you sort everybody? That's the thing. You can sort based on length. And then path length is 2 times, and each one is 10. So yeah, we can build a try. Okay, so you now have a try. Then what? Well, once you have a try, we can build out. And the thing is, can you get the whole thing without using a try? Like, how do we do that? Well, the longest, right? The longest. Yeah, either the longest are definitely pointing to the leaf. So you take that, right? You take that, and each one is lower English case letters. So each one can be multiple letters. It's not just one. It can be multiple. I think this is allowed, like this. Yep, this is allowed. If you see, yeah, this is allowed. So if I do size, we have level 1, level 2, but you're not sure if that is the final level, right? Oh, you can like do what we did yesterday. You put the slash, right? You put the slash between everything, and then you sort it based on lexicographically. Okay? Now you know immediately who you have all the paths. Yes, this will actually be faster than using a try. So now you have all the paths. Okay? Now what you want to do is to see if any two has the entire sub, which means you want to find if any two strings share their suffix, right? Essentially, that's what we're looking for, the suffix, because two folders are identical if they contain the same non-empty set of identical subfolders and underlying subfolder structure, which means the entire suffix has to be the same. So what we can do now is we take those out and we need to, I don't know, what would be the easiest way to go through this? So we go through everybody. We go through everybody to see the last one. So you have to go, maybe this is when we do a try. Maybe this is when we do a try. We go from right to left, we do a try. Right to left, we do a try. So what will happen is you will have, like in this case, if we go right to left with a try, what we're gonna have is, this will be y, right? Actually, no, let's do a try. So this is the root. We'll have a y, x, b, a, and then done. We can actually put the whole thing in there, and then this will go a b, a c, and then done. And then this will go a y, and then we'll go to a w, and done. So after this try, then we'll, and then after the try, So the first one is to get these out, right? Maybe we can reverse it. I mean, I'm trying to think, like, what does this try do? Basically, we'll have this, and then we'll branch out. Maybe we'll branch out multiple, right? So when we hit the branch out point, so when we hit something which have multiple, then we know they all need to be deleted, which means these nodes will not be included. X and W will not be included, right? So if I traverse the try, go, and I hit this, right? I split out, then I simply, I go here to find that one, and we set saying that is a good start. So I say this is a good start. No, this is a good. This is a good path. Okay, good path. And then we will walk towards the front. I mean, when we get to the front, right? When we get to the front, all we want to know is, when we get to the front, all we want to know is how many gets deleted. Alright? So I keep track. Yeah, if I keep track the number of levels we go through, then that should be fine. Yeah, how many is different? So I keep track, boom, that's how many that's different. Right, the first time they split is sufficient. Because once they split, that means there's a difference, right? First time they split, then you have the number. Okay. Okay, I think this one will work, but can we not using try? I'm still trying to see if it's possible to reverse this. Okay, so I will attach everything, sort it in order to find the full path. Right, the full path is just, if you're not the previous one, right? The previous one. You know what the previous one is, and the current one, you just see if it's the same length plus 1, right? If it's the same length plus 1, no, it will drop, because once you sort it, it will just go go up, because it's guaranteed to be that way, right? So you just sort it, and then you walk from the front until the one, that's the longest so far. So that's the one. So you take it out, and you go to the next one, right? So because the sides just go up, go down, go up, go down, go up, go down, because it has to follow this type of cadence. They have to start with this 1, and it has to go by 2, and it has to go by 3, it has to go by 4. It has to be this way. Otherwise, it doesn't work, because I cannot have an AD, for example, right? So like in this case, I cannot have an A and D. The reason I cannot have it is Actually, I'm not sure if I cannot have it. Actually, I'm not sure. No two paths lead to the same folder. They don't lead to the same folder. They just have the same parent. Ooh, this actually I think is allowed. So basically we have A to B, A to D, right? And then C to DA. Yeah, I think this one is allowed. So you do allow this. Yep, yeah, this is allowed. Right, this is allowed. And I can even, let's say, do a CD. Right, so in this case, I have AB, I have CD, I have AD. Right, so in your case, it will be A and AB, AD, right, and then CD. So if I go this, I go the next one. Oh. Yeah, I go next one. I find the last, and so this has to be equal to this, to the last one. Right? So these two has to be the same. If the same, then yeah, we switch to this. And then the next one, they're not the same. Right? This and this is not the same because this and this is not the same. So once it's not the same, this one will be taken out. So I'll take this one out. And once I take this out, then this has to compare to this again. So it's like a stack, right? We do this, and once it's not the same, this one taken out, and then we'll keep comparing. Now these are the same, so I put this one in, and next CD comes. So CD comes, this is not the same, so this get popped, and this is not the same, then we'll pop this, but we should not pop this. What would be the good algorithm to even get there in the first place? Maybe try is the best one, honestly. Right? Maybe try is the best one. Okay, say you use a try, right? So you use a try and you figure out the root path, right? You figure you have a path on every single one of them. Okay, fine. Now you have that. Then what? Right? Then what? Because you need to do it in the reverse style. See, that's why I think I need a full path initially, right? That's what I need. I need a full path. But I'm finding it difficult even to get the full path. Or I can use a try, but after I do the try, I have to traverse the try again. Right? I have to traverse the try again. Maybe coming. Maybe a B. Yes. Alright, again, I don't want to build 2 tries, but I feel like I have to. Because it can branch, right? And if it branch... Wait, if it branch, doesn't that mean they will not share subfolders, right? Like, your problem is if I turn everybody into a string and I sort them, then strings like A, B, C, and A, let's say A, B, D, they are hard to tell apart. Like I have A, I have A, B, and I have A, B, C, A, B, D, right? So these are easy to tell that A, B, C follows A, B follows A. But A, B, C, and A, B, D, they're difficult to tell. However, because they diverge, if you draw it, it's going to be A, B, and then boom, a C and D. Then, oh, but if I keep going, let's say E, F, and this is also E and F, then these two need to be deleted. I want to see it. Seeing is believing. I need to see this. So you are telling me that if I have a lordy, right? So I have A, B, right? A, B, C, okay, and then A, B, D, and then A, B, C, E, A, B, D, E. I think this is enough. Right, so in that case, I don't have F, because it's just too much to write. So I don't have F. So what we'll get is just A, B, C, no, just A, B, because these two are deleted. So we just get A, B. Yep. That is correct. Yeah, I don't see any other way except from just, you have to build or to try. And then once you build a try, you will traverse this thing. Right, once you build a try, then you will treat this as a regular tree, and then you traverse it, and then you'll build this whole thing from leaf to the node. So essentially you will visit first, visit everybody, and then you will do this and you return, right? And then you will add yourself, and then you will return, right? So yeah. So back at the front, you'll have you'll have the whole thing. You'll have the in reverse. You'll have in reverse, right? You have in reverse. Then in this case, you have E, C. I mean, I don't even have to do all that. It's just going to be no, E, C, B, A. That's one will return, and E, D, B, A. That's one will return. And you do the exact same thing. You put this into a try. Then we have E, right? And then we have C, D, and then we have B, A. We have B, A, right? And then you go from down and up. And then what? Exactly, then what? Right, E, C, B, A, this is the first one we do. And then I have E, D. Right, so basically we go, right? We have something the same, right? Something the same, and then we go to the next one. It branches out. So this branching means all the way to this thing, everything needs to be deleted. I don't know, man. I don't know. think we just traverse, right? Boom, traverse, traverse, traverse. So you build a try, and then you traverse, and then you hit a node, and then it has only one children, you traverse. If you have two children's, right, you have two children's, then you know it's going to, they're going to delete that child, right? They're going to delete that child. So if they are going to delete that child, but you'll still go there, because you need to get what this one is. But here's the complication. It's, then you have duplicates, right? You have this, and you have this. Oh, okay, so we do the first try, right? And then we build it in reverse. Okay, so build it in reverse. Okay, so when we build in reverse, so at this point, I will get multiple, right? And then when I come back, I have 1. Let's say we have like E/C. This is from the point of view of B. I got EC. Right, I got EC. And then I also got E and D. Right, I got EC. I got ED. Maybe not the best way to structure this, but if maybe I should do it, then you will append in the front. Oh, that's alright, ECD. Right, I have EC, and then I have ED. Still think it's not. It's easier if you just get a whole thing, right? It'll be easier, you get a whole thing. And then once you get a whole thing, I run another try, right, from this down. But I'm having trouble, okay? I'm having trouble, so when I run this, I mean, it's all cool and fine, right, all cool and fine. But in this try, I gotta start something same, and a first split, right? First split. Once I got a first split, let's call it also DFS, right? I have the first split, then I know that these will be deleted, right? These will be deleted. So what I do is when I visit this, I'll say to keep, right? To keep, I can call this with a -1, so I know this one's still not to keep, right? I can set a really large negative value, so every time I just keep going. Oh yeah, we just keep the same negative value, -1, -1, -1, and then boom, I hit this. I call this a -1. What would be a good scheme to use here. Right, it's split. So I know split needs to, so I need to call this, right? But I need to give a signal to say this one's going to be deleted, but the next one's not deleted. Which one? You set this one to -1, right? Everybody, you start with a giant negative value. Okay, we have a gigantic negative value. So each time you go, just +1, +1, +1, +1, right? It doesn't really matter. It does not really matter. But when you're here, you set to -1, right? So next you +1, so this will be positive, right? This will be positive. So you will record this, right? So you recorded B, and then next, so this one will give me BA, let's say, and this one will give me BA as well. But let's say we put a set, so this one will only give me BA, and then I will turn this into this. Yeah, I mean, I guess it works, but I'm not gonna implement it. I think it's way too complicated. I have my solution, but I'm not gonna do it. It's like 2 tries and a bunch of other stuff. I want to see if there are any easier. Oh, holy crap! Looks so complicated again. Let's just see if we have the same idea. Hopefully it's the same idea. If it's not, that's also fine. Serialization. Okay, so my idea, what I'm afraid is it's going to run over time. Because you have to go through lots of steps. Like seriously, lots of steps. Let's see if we can get some inspiration from the official solution. Yes, exactly. We go through the abstract, we get our idea down, and see if it works. We build a tree of the file system using the input path. This tree is a multi-way tree record where each non-root node represents a folder. Traverse the tree string from the root as stated in the problem if 2 nodes X and Y contain subfolders with the... Well, I can technically, if I build this tree, which is like a... I want to say it's a try, right? It's a try. So you build it, and as you're building it, right? As you are building it, you will also return or put I mean, it is a try, right? It is a try. So maybe you can get the subfolder structure ready. So yeah, so you're doing a try, and then every time you hit a node, you will say this node has these subtrees, and all the subtrees the string will form a map, and the map will point back into the pointer of your node, right? So it's still a try. It's still a try. So the try node has a children, right? Has a children, and the try node will get the link to the next one. And the try node will contain the try node will contain, not the try node will contain. So when you hit this try node, you know what the subtree is, right? You know what the subtree is. Then what you do is you create the substring of the subtree, you put it into a map, and it will point into this try node. So basically we say this try node represents the root of the subtree, the subfolder, right? So yeah, you build this, and as you are building this thing, right? As you're building this thing, and we of course we sort based on the size, so you will always build the start first, right? So as you're building this thing, you're always trying to search if the subfolder is in the map. If it's in the map, then you can map to the try node, right? You can map to the try node. Yes, then you can set some value on the try node saying, yep, this is where we are going to, this is where the difference, well, I mean, if the so if, again, like try is different from the actual thing. So like if here I have A, I have B, as I have C, right? And the other one, so for A, for this one, I'll record like B to C, right? B to C is this, and here is just C, and this one I'll record like A, B, C. Of course, also AB, also AC. Doesn't matter. So they'll point into this. And now I have, let's say, a D. Let's just call it a. Ooh, what if this is a B? Good question. And what if this is C? Then what? Then they have subfolder. I think this is the whole this whole thing gets deleted. Then it will be empty. Because BC. Hold on. This will be interesting. I honestly don't know what's gonna happen. Let's borrow this. Right, A, B, C, and then we have B. I have B and C. Oh, this one will be funny. I think it's delete the whole thing. It'll be empty. Not empty, but A. Why? I have A, B, and C. I have B and C. because these two folders contain the same structure. Because you need to have a parent. So therefore, this one's deleted, this one got deleted. So that's why it's only A left. Okay, that's alright. But then in this case, this will get me B and C. So you have a match, right? So you say this match to this. That means once you have a match, so the subtree needs to be deleted. Right, so this needs to be deleted, and this needs to be deleted. Basically, mark this get deleted, and this one will mark this get deleted. Yeah, okay, it doesn't really work very well. Okay. Yep, that's fine. Okay, that's I think kind of like what we're doing. Yes. Yes. Okay, I think the tree has to be built differently. Right, so we have a root. So I need to build it like this. Right, it's not a try, it's like this. And then, so we build it, and then I compute the sub of this. So subtree of this is gonna be, so this will be like a C, this will be an empty, this will be empty, this will be a BC, right, and then this will be a C, and this will be an empty. Right, so I'll build this, which can be done, pretty simple. And when we traverse BC, does not exist, so this is, so A is a good thing. And then I traverse back to B, C I contain, so I just skip. And then we'll go here, B, C, so I skip. Yep, that is the solution. That is the solution. So, okay, how do I build this? How do I build this? Based on what we have. Like if you try, it's like a slightly different concept, right? A slightly different concept. Because when we get to the node, I don't know who get there. But technically we can include parent. Right? Technically we can include parent. So I can still do a try. Okay? I can do a try. And I go here. Huh. If I do a try, so this will do a BC. A will be pointed to BC, right? And I simply don't do it at the root level. Right? I don't do it at the root level. I just say, okay, I'm A. Right, I'm A. Moving down to this will represent, A. And I say, what is my remaining? What is my subfolder? And my subfolder can be, I don't know. at that time, right? Is I'm gonna A. I don't know what my subfolder. And that's the thing, because you can branch, right? You might branch. You might do this, right? You might branch out. So when you hit here, you don't really know what your subfolder structure is. So you have to let it go. And then you come back. So this is C. I can say this is going to be empty. This is going to be dash C. And this is going to be empty. This is going to be dash D. So when you come here, right? So this one actually has both. It has a C. You have a BC. It has a CD, right? So this A, this one actually has both. And this is a dash, this is a dash C, and that's it. We don't record at the top, right? We don't record at the top. So now I'm gonna traverse again, right? I go to A, I come to this, and I find, I just go through everything. BC, does it have CD? Does it have? No, it doesn't. So A goes into the thing, right? And I keep it. Go down. This C contains, so we don't do it. Okay, try can do it. We can use try. We can use try. Alright, I am not implementing this, but I get the idea. Yeah, they use a try node as well. Serial just one? Just one. Really? It works? It works. I feel we need both. Oh, I see what serialization means. Oh, so like if I say if A needs to be deleted, then the representation of this whole thing need to be the same as something else. If only one branch is the same, the other branch is not the same, then you cannot. But if we don't serialize it, then we have to do. Okay, so you have to serialize it. Okay, makes sense. We need to serialize. So how do we serialize this? If X has children, so yeah, if it has multiple child, so we get a serialize for each one of them, and then we put their serialization together. right? So we'll serialize this, serialize this, serialize this, and everyone will attach to themselves. And then that will be its serialization. So this basically is a representation of the entire subtree. Attaches a folder name in front and a wrapped structure in parentheses. Or sense if x1 and x2. So you have to do an ordered, right? You have to do an ordered map. Yes. 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 So after one post order, you have this. Collect unique path. Yeah, DFS will work. More than once, then it's a duplicate. It should be skipped. That's a try. Delete duplicate folders. Have a root. New try. Yeah, this is building the tree. I can understand. We prepare the hash map. So this is serialization. A try node. Return empty string. Just write a separate function. Jesus. No children. We have a folder. We have a child. What's this construct child do? Oh, this is a construct. So yeah, so you do that. You have a serial and a Vita pushback. Folder plus this. That's fine. And then you sort here. You sort here. This is the string with all the children with their folder. And you sort this. And then plus equal to. We can use other way to do that. And we will have my serial. I add it to the frequency. Okay, I understand what that does. Then this is the last one. This is the result. And the path from the root. Yes, I need to record the path from the root. So I'll go. If this is larger than 1, then we don't do it. Otherwise, we'll add the path to the answer. We'll push back the path, which I think will create a copy, right? And then I'll just, for the children, for the children, I always push back the current folder. Where do I update the path? Operate child. I don't see the code to push the path. I have path.popback. Oh, my bad. This is the path. Okay. So, yeah. I'm not implementing this. Jesus. I'm not implementing this. For crying out loud. I'm not implementing this. Because it is too complicated. I understand the idea, right? But the implementation is how should I say? I understand the idea, and the main trick, the main ingenuity is to use to represent, to find a string representation of the state of the subtree, and use a counter, right, to keep track each subtree state's frequency. Yeah. Other than that, the solution is fairly clear. Yeah, I think I understand. No implementation for sure. That is way too long to implement. I have to go through a lot of hoops. But overall, where are we stuck? I'm thinking to kind of build 2 tries, and then, yeah, I think it will work, but I think it will also time out. I think the real ingenuity is indeed the hash map. The hash map is the ingenuity, which I didn't realize until I read the hints. So we'll submit this and just call it. Yeah, just call it. Yeah, this one's pretty bad. So we put into the nightmare. It's pretty bad. But that'll be it. And I'm not doing this again. Jesus. Alright, I'll see you guys tomorrow. Adios.